Hello and welcome. In this video, we'll try to find the domain and range of this form of the quadratic polynomial. That is the quadratic polynomial in the denominator. F of x is 1 over ax square plus bx plus c. Whenever we are trying to deal with these kind of problems, it's better to find the domain of the functions first before finding the range. Because since the quadratic polynomial is in the denominator, some values of x may put this quadratic polynomial to 0, and such values of x are called roots of the polynomial. So whenever we put such values of x to this, the denominator goes to 0. Whenever the denominator goes to 0, f of x will fail to give you finite values. So f of x will give you undefined values. So in such cases, those values of x, we cannot include them into the domain. So it is better to find the domain first. So in order to find the domain, we need to find the roots of the polynomial first. So to find the roots of the polynomial, first let us see whether the root exists or not. To find the roots exist or not, we need to find the discriminant of the function, discriminant of the quadratic polynomial, where discriminant is defined as b square minus 4ac. So here a is 1, b is 5 and c is 6. So b square is 6 square, sorry, b square is 5 square, b square is 5 square, minus 4 into a is 1, c is 6. So which is 25 minus 24, which is 1. So since d is positive, since d is greater than or equal to 0, roots exist, real roots exist. So now let us find the roots. To find the roots, what I'll do is, I'll take the function itself, the quadratic polynomial, x square plus 5x plus 6. So the product should give me 6x square and the sum should give me 5x. So I can take clearly 3x and 2x. So this is x square plus 3x plus 2x plus 6. So x into x plus 3, x into x plus 3 plus 2 into x plus 3. So this is x plus 2 into x plus 3. So the roots of this quadratic equation is, roots are x plus 2. How to find the roots? Let us equate this to 0. So x is equal to minus 2 is one of the roots and x is equal to minus 3 is one of the roots. So at minus 2 and minus 3, this quadratic function goes to 0. So which makes 1 by 0 an undefined value. So at these values, f of x fails to produce finite values. So these two values, we cannot include them into the domain. So f of x, I can also write it as f of x, in a different form I can write as f of x is equal to 1 by x plus 2 into x plus 3. So the domain of this function is, except x is equal to minus 2 and x is equal to minus 3, we will get finite values of f of x or any values of x which belongs to real number. So we can take any number in the real number, set, except values like minus 2 and minus 3. So this is my domain. So with the help of the domain, we can try to find the range of the function. So let us see how to find the range. Before that, I will show you how the domain looks. So we have two roots, minus 3 and minus 2. So at these points, the domain will not be there, except everywhere else we have the domain like this. So this is my domain. Now how does the curve look is very important here. Let us take, we have f of x is equal to 1 by x plus 2 and x plus 3. So here this is also equal to x square plus 5x plus 6. So here the coefficient of x square is 1, which is positive. If a is positive, then the curve will look like this. Let us write like this, dotted line. So if you put x is equal to minus 3, you put x is equal to minus 3, so f of minus 3 will be 1 by minus 3 plus 2 into minus 3 plus 3, so which is 1 by 0, which is infinity. So from minus 3, at minus 3, the curve starts at infinity, very large value, and goes to 0 like this. Similarly, when f of x, when x is equal to minus 2, when x is equal to minus 2, f of minus 2 is also infinity. F of minus 2 is 1 by minus 2 plus 2 into minus 2 plus 3, which is 1 by 0 into 1, which is 1 over 0, which is infinity. So from minus 2 also, it starts with a higher, greatest value, the infinity, highest value, and it goes to 0 like this, because f of x 1 by x square, if I have functions like this, limit extends to infinity, f of x is 1 by infinity, which is 0. Even if it goes to minus infinity also, which is 1 by minus infinity square, this is also 1, this is also 0. So this 2 goes to 0, but we have domain in this interval as well. So what is the value at this point between minus 3 and minus 2? So to find that we have to find the range of the function. It is what, to find that we need to apply the completing square method. So what I suggest is apply completing square method. If you apply completing square method, you will get the form like this: a into x plus b by 2a whole square plus minus b square by 4a plus c. This is what we get if you apply quadratic polynomial to any quadratic functions. If you apply completing square method to any quadratic functions. So here a is 1, b is 5, and c is 6. So f of x is equal to, I can write this as 1 by a is 1, so x plus b by 2a, 5 by 2 into 1, so which is 5 by 2, this is my vertex, plus minus b square by 4a plus c, I will do it separately, minus b square, so minus is formula minus, b square is 25 divided by 4a, 4 into 1 is 4, plus c is 6, so this becomes minus 25 by 4 plus 6. Oh, I can simplify this. Minus 25 by 4 is actually minus 6.25 plus 6, which is minus 0.25, or I can write this as minus 1 over 4. So this is my minus 1 over 4. This is the final form to which we have to bring after applying completing square method. So what does it mean? It means at minus 5 by 2, at x is equal to minus 5 by 2, we have a vertex. So if you equate this to 0, you get x is equal to minus 5 by 2, which is the vertex. When you put x is equal to minus 5 by 2, this value goes to 0. So you'll get the value f of minus 5 by 2 as 1 over minus 1 by 4, which is minus 4. So at minus 5 by 2, so somewhere here we have minus 5 by 2, which is minus 2.5. This is my vertex. At this point, the value is minus 4, minus 4. So this is the maximum value it attains in the negative axis, in the negative y-axis. The curve would look like this. It attains minus 4 and it goes to minus infinity, and here also, from here also it goes to minus infinity. So this diagram helps us to find the range of this particular function. So the range is from minus infinity to minus 4, minus infinity to minus 4, and from 0 to infinity. So this area is not included in the range. We do not include 0 also because this curve approaches 0. It will not touch 0, but it approaches 0, so we cannot include. In some textbooks, even in standard textbooks, they have only given from minus infinity to minus 4. They have not included this part, which is wrong. So if in any exams, if you don't get this option, and if you get only this option, then you can tick this answer. If you have this option, you have to tick this one. Let us solve another. Okay, let us verify this in the graph plotter. The equation is 1 by x square plus 5x plus 6. Yeah, let us verify this using the graph plotter. One over x square plus 5x plus 6. You can see the value over here is minus 4. From minus 4 to minus infinity, and from 0 to infinity we have range. At minus 3, you can see at minus 3 and minus 2 we have an infinite value. Let us solve another problem. This is minus 4, and you can also see the vertex is at minus 2.5, which is minus 5 by 2, and at minus 5 by 2 the value is minus 4. Let us solve another problem. So this is an interesting problem. We have negative a here. A is negative. Let us find the domain first. The domain. To find the domain, let us see whether the root exists or not. Here a is minus 1, b is 5, and c is 6. Let us find the discriminant. Discriminant is b square minus 4ac. B is 5 square. B square is 5 square. B is 5. 4 into minus 1 into 6. This is 25 plus 24, which is 49. So D is positive. So roots exist. So let us, if root exists, let us find the roots. Let us find the roots. We have minus x square plus 5x plus 6. So minus 6x square is my product, and the sum is 5x. So I think we can take 6x and 1x with minus 1x, because the product is negative, the sum is positive. So I can write this as minus x square plus 6x minus x plus 6. Take minus x outside. I'll get x minus 6. If I take minus 1 outside, I'll get x minus 6 as well here. Minus x minus 1 and x minus 6. So further I can write this as minus x plus 1 and x minus 6. So the roots are x plus 1 is equal to 0, x minus 6 is equal to 0. The roots are x is equal to minus 1 and x is equal to 6. So at these points, this quadratic polynomial goes to 0. Hence, these points are not included in the domain of the function. So f of x, I'll write f of x as 3 over minus x plus 1 and x minus 6. So the domain of this function is all real numbers except minus 1 and 6. So except these two values, you can take any values in the real number and put it into f of x to get a finite value. This at minus 1 and plus 6, we don't get the finite value. Next, in order to find the range, In order to find the range, let us try to plot this function. Try to plot this function. Start like this. At -1 we have a root. At +6 we have a root. This point, the domain does not exist. Let's write dotted lines over this. Since a is negative, at the roots, it starts from -infinity. So from -infinity, it goes to 0 like this, and at 6 it even at x is equal to 6 it starts -infinity. You can verify that. Let's see how to verify that. We have f of x is equal to 1 by minus x plus 1 x minus x. If you put x is equal to -1, this term will be 0. So 0 into this also 0. So we'll get f of -1 is equal to 1 over minus 0. So this is -1 by 0, which is minus infinity. So this starts from minus infinity. If you put x is equal to minus infinity, f of minus infinity is equal to 1 by minus infinity into infinity, or you'll get -1 by infinity, which is 0. So at the roots it is minus infinity, and at minus infinity is 0. So it comes from negative infinity and settles down to 0 like this. So the negative y-axis is covered. Then how to find what values it covers in the positive y value? So for that we'll take the help of completing square method. So we know that f of x we can write as, if I have a quadratic polynomial, we f of x we can always write this as 3 by 3. Anyhow, you keep 3 as it is. So this quadratic polynomial, if you treat this as ax square plus bx plus c, we can always write this as a into x plus b by 2a whole square plus minus b square by 4a plus c. This is what we have seen in previous videos. So let us apply for this function. F of x is equal to 3 divided by, what is a? A is -1. So I'll take -1 x plus b by 2a. b by 2a b is 5 minus 2 into 1, because a is -1. Or you can write this as 2 into -1, which is minus 5 by 2. So I can write this as x minus 5 by 2 whole square plus I'll write minus, I'll find this value, minus b square by 4a plus c, minus, what is b? B is 5, so 5 square divided by 4 into -1 plus c is 6. So minus 25 divided by -4 plus 6, which is minus and minus I can cancel out. 4 6 are 24, 6.25 plus 6, which is 12.25. Or I can keep it in fraction, because we have 3 in the numerator. So I'll have 25 plus LCM. If I take 6 into 4 is 24 divided by 4, which is 49 by 4. So this value is actually 49 by 4. So this is the standard form I have to bring in. Now what is this value? This value, x is equal to 5 by 2. If you equate this x minus 5 by 2 to 0, we'll get x is equal to 5 by 2, which is my vertex. So somewhere here I get 5 by 2. So at 5 by 2, what is the value? If you put x is equal to 5 by 2, we'll get f of 5 by 2 is equal to, this term goes to 0. So I'm left out with 3 divided by 49 by 4, which is 12 by 49. That 5 by 2, 5 by 2, the value is 12 by 49. And from here, this is the minimum value. From here, it goes on and take infinity like this, and it goes to infinity like this in this region as well. So this helps us to find the range of the function. So what is 12 by 49? Let us calculate and see. 12 over 49 is 0.244. 0.244. So this is this value is 0.244. So let us write the range for this. So the range of this function is, from in the negative y-axis, covers minus infinity to 0. 0 is not included because it is approaching 0, not never 0, and union 0.244 to infinity. So let us verify this in the graph plotter. 3 by, this is 3 and this is minus negative. Let us see. So this is what the graph looks like. -1 and -6. This is -1. -1 we have minus infinity, plus 6 we have minus infinity. This is the minimum value, as I told you. The vertex is 2.5, and at 2.5 the value is 0.245. That's what we got as well. 0.2449. It is 0.245. Let us solve one more problem. Okay, so let us try to find the domain of this. If you write f of x as 3 into this, since we don't have x term here, it's easy to find the roots. Minus x square plus 2, or I can write this as root 2 whole square minus x square. So I can apply a square minus b square formula, which is a plus b into a minus b. So this is root 2 minus x and root 2 plus x. So the roots are root 2 minus x is equal to 0. The roots are root 2 minus x is equal to 0 and root 2 plus x is equal to 0. Root 2 is equal to x is equal to minus root 2. So x is equal to plus root 2 and minus root 2 are the roots. So f of x I can write as 3 by minus x minus root 2 and x plus root 2 I can write, because we have 3 minus root 2 minus x and root 2 plus x. So from here I took minus outside, I can write this like this. So the roots are root 2 and plus root 2, root 2 and minus root 2. So if you plot this at minus root 2 we have a root, and at plus root 2 also we have a root. So this will not be included for the domain. So the domain of this function is all the real numbers except root 2 and minus root 2 and minus root. So how does the curve look? So at root 2, since a is negative here, a is minus 1, curve comes from minus infinity. So from minus infinity, it goes to 0 like this, and other root also comes from minus infinity and goes to 0. And what is a vertex and what values it covers? In the positive value is important. Let us see. So let us write using quadratic polynomial completing square method, which is 3 by a into x plus b by 2a into x plus b by 2a plus minus b square by 4a plus c. If you don't want to remember this formula, you can apply completing square method to this function only. Then you will approach to this value as well. But that takes time. If you can manage, then no problem. 3 divided by a is minus 1. Here from this equation, a is 1 minus 1. a is a is minus 1. b is 0. c is 2. So I can write x plus b is 0. So this is 0 plus b square minus 4a. This becomes also 0. Value of c is 2. So this I can write as 3. And this is in the standard form only. No worry, no problem. Need not to write again. So here my vertex is x is equal to 0. So at 0, the value is 3 by 2. If you put x is equal to 0, this whole term goes to 0. Value is 3 by 2. So at 0, at 0, we have value 3 by 2, which is 1.5. So from here, it goes to infinity like this, and it goes to infinity like this. So it will not cover this value, this interval y. So the range of this function is, the range of this function is range is from minus infinity up to 0, union 1.5 is included. 1.5 is included. 1.5 to infinite. Let's solve one more problem. This is an interesting problem. Let us try to find the domain. To find the domain, let us see what are the roots of this. A is 1, b is 1, c is 1. Let us find the discriminant, which is b square minus 4ac. b square is 1 minus 4 into 1 into 1. 1 minus 4 is minus 3. So d is negative here. D is negative. So no real root exists. No real root exists. What does it mean? Whenever there is no root, the curve will not go to 0 itself. If you put any value of x, the curve will not go to 0. So in such cases, whenever the real root does not exist, the domain of such functions are complete real number. Domain is all real number. So because it never goes to 0, the denominator never goes to 0. Since denominator never goes to 0, you can take any real number. So domain is complete real number. So now let us find the range. Let us find the range. So here a is positive. Let us use quadratic completing square method. Of x is equal to 3 divided by a into x plus b by 2a plus minus b square by 4a plus c. So this is 3 divided a, b, c are all 1. So a is 1 and b is also 1, which is 1 by 2 plus minus 1 square is 1 divided by 4 plus c is also 1. So this is 3 divided by x plus half. So this is square actually. 1 minus 1 by 4 is 3 by 4. So what does the curve look like? The curve anyhow, it is complete real number, the domain, so it never touches 0. The vertex is From this, I can write the vertex is x is equal to minus half. So at minus half, what is the value? The value is f of minus half is, this goes to 0, 3 by 3 by 4, which is 12 by 3, which is 4. So at this point, it is 4, it is 4. And after this, since it is in the denominator, 3 divided by x square plus x plus 1, if you increase x to infinity, so this becomes 3 by infinity, which is 0. So it has to go down to 0 like this. And at minus infinity also, it goes to 0 like this. This is what the curve looks. So the range of this function is 4, from 4 to 0. So this is my range. The maximum value it takes is 4. 0 is not included because it approaches 0 as x tends to infinity. So let us verify this. We have 3 by x square plus x plus 1. So you can see from 4 it goes all the way to 0. Okay, I'll encourage you to solve some problems of this kind when x is negative. When x square, the coefficient of x square is negative, sorry, when a is negative and there are no real roots, I'll encourage you to solve. So what I say is, if I have minus x square plus x plus 1, problems like this, if the roots does not exist, curve will look like this. So it will take some value and it goes to 0 like this, though the range will be again from this point to 0. Thanks for watching.